So my name is Daniel, and the rest of the members in my team are Nihal, Gibran, and Hamza. So our project is basically a game जिसमें which is very similar to a maze runner, जिसमें हमारे पास एक specific amount of time होगा और हमें we have to collect three diamonds that are spawned throughout the map or maze, and we have to basically escape with them. तो इस लूप को थोड़ा इंटरेस्टिंग बनाने के लिए एंड टू मेक इट मोर चैलेंजिंग एंड कॉम्प्लेक्स हमने एक विजिबिलिटी एक्सपेक्ट रखा है गेम के अंदर, जिससे कि प्लेयर का एक सर्टेन रेडियस ही उस आपको शो हो रहा होगा स्क्रीन पे, कि फॉर एग्जांपल कि पूरा मेज अगर है तो उसका एक सर्टेन रेडियस उतना ही प्लेयर को शो हो रहा होगा और बाकी का जो मैप है या मेज है वो ब्लैक डार्कनेस में कवर होगा। तो इसकी वजह से गेम में थोड़ी चैलेंजिंग आएगी कि प्लेयर को खेलने मजा आएगा कि आगे जाके एक मिस्ट्री क्या है मेज, आगे जाके अगर वो कोई भी ब्लॉकेज है या नहीं है, किस तरह से मेज कहाँ पे जा रहा है, तो वो प्लेयर से हिडन होगा। जैसे ही आगे आगे मूव करता रहेगा उतना ही रेडियस उसको शो हो रहा होगा और मेज उसी हिसाब से उसको सामने आ रहा होगा। तो ये बेसिकली हमारा एक गेम लूप है और एक तरह से जो गेम लॉजिक इस तरह से है। तो अगर हम डिवीजन ऑफ वर्क की बात करें तो जिब्रान ने डार्कनेस एक्सपेक्ट पे काम किया था, विजिबिलिटी वाले एक्सपेक्ट पे काम किया है मेज के। और हम सब ने ही मिलके, निहाल, हमजा और मैंने सबने मिलके जो मेज डिज़ाइन और मेज की कोलिशंस पे काम किया। उसके बाद आखिर में निहाल और मैंने जो कि इनपुट है जॉयस्टिक के साथ और स्टार्ट स्क्रीन पे काम किया। सो बेसिकली जो हमारा इनपुट ब्लॉक है, जो इनपुट जिस तरह से ले रहे हैं, हमने जो डिसाइड किया था कि हम जॉयस्टिक से एक मेन इनपुट डिवाइस हमारी जॉयस्टिक होगी, जो कि प्ले जिससे जो आपका प्लेयर है वो करेक्टर की एक्स और वाई डायरेक्शन को कंट्रोल कर रहा होगा। हमने किस तरह से किया था कि जॉयस्टिक को इस्तेमाल करने के लिए हमने 15.6 ओम के रजिस्टर कनेक्ट किए ब्रेड बोर्ड के साथ, और फिर उसमें सारे कनेक्शंस M2M केबल्स के साथ कनेक्शंस किए एफपीजी बोर्ड में, और उसके बाद जो लॉजिक है उसकी इंप्लीमेंट की कोड में। लेकिन वी फेस सम प्रॉब्लम्स जो कि हमने आगे जाके चैलेंजेस में भी डिस्कस किया है जॉयस्टिक की इम्प्लीमेंटेशन के साथ। इसलिए हमने एक बैकअप पे यूजिंग कीबोर्ड एज अ ऑप्शन रखा है।
So I'll explain to you how our control block works. Basically, our control block sits between the input and decides the outputs to be shown. So as the player presses the buttons, the character is being animated based on position X and its position Y, which is being depicted over here. Through every clock cycle, we're going to be changing the value of the X and the Y, which are X and Y coordinates of our character. Now, when it comes to our maze, we made use of certain wires which actually define the borders of the maze. And we've also used certain wires to define collisions. And we've enforced essentially that if there isn't a collision, let's say on the right side, and the signal coming in is signal to go towards the right side, then we'll make sure that the exponent of the character is being increased. And the same applies for the left, up and down, as you can clearly see here. We've also instantiated, we've also incorporated essentially restart functionality. So whenever the player presses the restart button, which we've assigned for now to be the middle button or FPGA, then they'll go back to the original position, which was 0, 30. Right. So we've created collisions and we've created the walls via wires. And we've also added this unique feature wherein we define an area of visibility denoted by this Y square. And we make sure that every pixel that is within the field of square, which we've defined via formula for a circle in Cartesian coordinates. If it's within this range, then it should be visible, else it should be black, as is denoted by the ternary operator, where if you pass 0, 0, 0, you're going to get black. Right. So another thing we've incorporated in the game is that we have a start flag. So if you can see over here, start game, only if the game is started. So according to our design, we assign a pin, and the pin is actually W13. So once that pin is set on, then and only then will the game begin really. So according to our report, this is what start game image looks like. Yes. And this is just a snippet of all the conditions we made use of in order to animate the walls as well as the collisions. Right, so this is the picture of our state transition diagram. There's a running state, there's a player generation, and there's well the image generation. And depending on the inputs of the joystick, well, this is our plan A, and in case it failed to be encoded with the keyboard, depending on the player's input, there will be movement. And now, depending on whether there is collision with the wall or with a diamond, they get the appropriate responses. If they collect all the diamonds within the time limit, then they have won the game. And if not, if the time has elapsed completely, then they have lost the level. I hope that was a comprehensive explanation of our control block. Thank you.
Okay, so this is our final maze, where the primary objective is for the player to find their way out. But solving this maze seems pretty straightforward. Well, there's a little twist here. Now, this is the final look of our maze, but wait a second, where is the maze? Well, the maze is still there, but only a small radius around the player is visible. As the player moves through the maze, this visible area changes based on the coordinates, and the part of the maze leaves behind and becomes dark again. Now, to win this game, a player must not only find the exit within 30 seconds, but they also have to collect 3 diamonds that are placed gradually throughout the base, which will allow them to go through the exit. If a player reaches the exit failing to collect one or more diamonds, they will lose.
Okay, so the one of the major problems we faced in this project was the implementation of the joystick. The main part or the hard part of implementing the joystick was the resistors were the main issue because the resistor were all mixed up in the bin and we couldn't figure out the exact amount of resistance it should apply. Like we did test with it, but in the end it was causing problems. The movement of the joystick hence was not properly implemented, and there were issues with the voltage because of the incorrect resistance. Another problem we faced in our project was displaying the images. We found a link on the GitHub which we used just to display the images onto the screen, but given the memory constraints of the Basic 3 board, it was very difficult to display large images. So we were forced to hardcode the maze and even the start and end screens because even those were taking a lot of memory and it was just impossible to use them. We found a B project on GitHub from which we took help in displaying character assets onto the objects of a game, and it provided us a sense of how to structure our code.